Hello and welcome to another video on sets. This video is going to cover Venn diagrams, which is actually a nice topic because it's very visual. That's the whole point of having a Venn diagram, is for things to be more visual and more easy to understand. So let's get right into it. Venn diagrams, what do they represent? They represent sets using two or more circles or ovals with the element of a set, or the elements of a set, labeled within them. Turns out they can actually just be a single circle too. It's just very rare, and it's not as helpful usually. But I will write that there just to be, I guess, complete with my notes here. Can actually be a single circle as well. Example 1. Oh, by the way, I'll come back to this, or we'll see what this stuff means later. It's just a little foreshadowing. Example 1, draw and label a Venn diagram to represent the following set. R, counting numbers less than 7. Okay, well the counting numbers less than 7 are the numbers 1, 2, 3, 4, 5, and 6. So a Venn diagram is literally just a circle. So you can just draw a basic circle, maybe put an R on it so that you know that this is representing the set R, and just toss your numbers inside. 1, 2, 3, 4, 5, 6, 7. And there's no special way that you need to organize these numbers. You can move them around anywhere. They can be in whatever order or whatever place in the circle you want. The important thing is that all those numbers are in that. And I just realized it's less than 7, so it shouldn't have the number 7 in there. So again, when I say you can move them around wherever you want, you can have 5s and 6s, you can have 6s first, you can have 3s up top, you can have 2s down bottom. It doesn't matter as long as all the numbers are there, okay? But it's easier to read it if you have an order or a method to your madness. Let's try another example. Draw and label a Venn diagram to represent the set G, where G is the set of primary colors. Do you know what the primary colors are? Do you remember from way back when what the primary colors are? Primary colors are the colors red, yellow, and blue. So we can say this is our Venn diagram. If you want to be fancy and use a drawing program to make a circle, you can, but all you need to really do is have a G, and you got to put the primary colors inside, the names of them. So anywhere in this circle, we can put the name for the color red, we can put blue, and we can put yellow. All right, nothing fancy about it. You could write onto the side what that actual set would look like. You could say red, blue, and yellow. You can write it in alphabetical order or not. I'm just making a little sketch on the side, so alphabetical order not necessary. But the Venn diagram, this is the piece that's really important. Let's try another example. Given that B is the set of all English vowels, draw its Venn diagram. So once again, I've got my set B, and I want to toss all my English vowels inside. What are my vowels? A, E, I, O, U are my vowels. So A, E, I, O, U. Maybe you want to put an I in the middle there. Maybe you want to make your diagram look pretty and spread your A over there and your E over there. Make it all balanced. You can have fun with these diagrams. Use a little bit of your creative side. It's up to you. But at the end of the day, you should have a circle with all the elements inside, and then someone looking at it should be able to easily pick out what's in that set. Example 4. Let A equal the set 1, 2, 3. Let B equal the set 1, 2, 3, 4, 5. Show A as a subset of B, or in other words, show A as a subset of B using a Venn diagram. So what I like to see, or what I want to point out here, is that B is the bigger one. And you can hopefully see A is going to be a subset of what the set B has. So I've got the set B, I'll make that the bigger one. I'm going to put the set A inside it, and I'm just going to write out what the numbers in the set A are. 1, 2, 3. So once I've considered those numbers, I'm going to write the numbers 4 and 5 outside of that. And hopefully you can see why I'm doing that. I'm not going to rewrite the numbers like 1, 2, and 3 outside of that. Because even though that is in the set B now, and not in the set A, I mean, they're already in the set A. I'd be repeating myself, right? And I'd be actually wasting a lot of time by doing that. So let me be clear. My set B, if you look at just the set B, you can hopefully see that I've got all my numbers inside the set B. All right? The set B is all these numbers. The set A is all of these numbers. 1, 2, 3. That's these. The Venn diagram takes care of all the information. It sums it all up really nicely. It's a beautiful method, really, quite literally beautiful. If we wanted to, if we were just given this diagram now, we could get the sets A and B. And hopefully you can see that that's true, right? You've got the set A, you've got the set A inside of set B, but really you still got the whole set B there. It's just everything wraps up nicely. So sometimes this is a bit of a circular logic situation. If you're given the set, you can make the diagram can give you back the set, and everything works nicely in concert with each other. So the nice thing about Venn diagrams is that it doesn't just let us see the sets easily and the subsets. It can let us do operations very, very simply, or at least relatively simply. So regular arithmetic has 4 operations: add, subtract, multiply, divide. Set theory has 3 basic operations: intersection, union, and complement. So these are extremely important, but we've kind of already seen these before. In a way, I mean, intersection actually sort of means and. The logical operation and. Union sort of means or. And complement means, well, we've literally seen complement before. That's the opposite. That's not. That's negation. Okay? So let's see how we can use what we've learned before to help us understand this. Intersection. Like it says here, fun fact. The intersection symbol is similar to the logical symbol for and. So look how close they are. It's almost like if you took this symbol and just kind of squat down the edges, you'd end up getting that and symbol. The intersection of 2 sets is all the elements they have in common. So it's the ones that are in both sets, the one that's in the first set and the second set. Let's see what this example is showing us. Let x equal 1, 2, 3. Let y equal 3, 4, 5. Find the intersection of x and y using a Venn diagram to visualize it. Well, this is how we see it. X intersect y, or a and y. What is common to both? What is in x and y? 3 is in x and y. So the intersection of x and y is just the number 3. And this is how you would look at it on a Venn diagram. X is the numbers 1, 2, and 3. Y is the numbers 3, 4, and 5. 3 is in common. You would just kind of remove that from the set x and write the rest of the numbers. And you would remove it from the set y and write the rest of those numbers. Intersection acts sort of like a subtraction. It's like if you have the intersection, you know what's left over, right? So you can use a pencil to shade or whatever you need to do, but it says shade the intersection on the Venn diagram. So you should take a pencil or something similar and do some shading like this with the pencil, okay? I wonder if I can send that to the back. Send to back. Oops, that's not what I meant to do. So what I'm going to do, I'm going to highlight it with my highlighter because I can, but if you've got a pencil, just lightly shade it, okay? You'll shade it the way that I showed you, or some students just take lines and they'll shade it this way. Find a method that works for you. As long as it's shaded, you've completed the question properly. All right? So have we done everything? Did I find the intersection? Yes, I did. It's the number that's in sets x and y. It's in the set A, set x and the set y. What about union? Union is when we combine both sets together. Just like a marriage between two people is said as to be a union between the two people's families, well, two sets, when we do the union, we add them together. And it's similar to the logical OR. So we're adding the sets together is really what we get. So if we want to take union of x and y, we literally take the two sets and add the elements into one big set. So that would be the set 1, 2, 3, 3, 4, 5. If I literally took one set and added it to the other set, I'm putting them all into one big set. But that's really not necessary, is it? What's going on here? What's the problem? Well, I've repeated the number 3. So we can cancel that because repetition, repeated elements don't count. They don't change the set. And my final answer would be this. All right, let's see it on a Venn diagram. This is my diagram. I'll say this is x, this is y. Did I label the previous one? It was already labeled, okay. It already made it for me. I had to make my own this time. So x and y, the union, well, it's the exact same thing. They still have 3 being intersected. They still have the set x, 1 and 2. They still have the set y being 4 and 5. Hopefully you can see how these things are all being related to each other. But the difference is that everything is being shaded this time. So take your pencil and carefully shade the whole thing. And hopefully you can see now why it looks like that little diagram I drew above, or I included above. Right? The union is everything together. One way of thinking about this is that union, first of all, the U is in it, U, but it can be seen as a cup. And a cup holds many, many, many things, right? If you take a U, it can hold lots of stuff in it. So union is when we fill up a cup with lots and lots and lots of elements. Whereas intersection is more of a cap. And it has this shape. So it has a harder time filling up with items. It just has the intersection. That's a harder one to make sense of, but the union you should think of as a cup. All right? And I think you'll get far thinking with that idea. Union being you add all the elements together. So this video, you should take a moment to watch it now. It's only 5 minutes, almost 6 minutes. Take a moment to watch it, see if you can make sense of unions, intersections, and just Venn diagrams in general. Especially if this is the first time you've dealt with Venn diagrams, it's a good idea to see it from a couple different perspectives, okay? So I've given you my perspective on it, and if you watch this video, you'll get a really full picture of what a Venn diagram is and how it can do our operations. So you might remember, I said there was 3 operations. I said there was union and intersection. What's our third operation that we haven't talked about yet? Well, that's complement. And we can't talk about complement until we talk about what's called the universal set. The universal set is the set of all elements for a situation. Now, of course, these sets that we've been talking about, sometimes they're numbers, sometimes they're letters, they could be colors, they could be all sorts of things. The universal set is going to be laid out at the beginning of a question to tell us all the things we're working with. It's the universe that's been set for that particular question. So, for example, if we're discussing animals, you could be all animals on Earth. Okay, all animals. So if it's the set of all elements, you generally, well, if we're talking about animals, it's all the animals. Or if we're discussing Marvel characters, you could be all the possible characters in the Marvel universe. Now, not the DC universe, the Marvel universe. Marvel characters don't generally know about DC characters, and DC characters don't know about Marvel. Just like, there's all sorts of examples you can give with this. But you create your own universe for the question. So it's represented by a large rectangle surrounding a Venn diagram. So you'll notice that you have your rectangle here. That's what we call the universal set. It holds all the elements inside it. Every set in a question is a subset of the universal set. So that's the pro tip on the bottom here. Every set is a subset of the universal set for a given situation. So for example, A is definitely a subset of U. B is a subset of U, C is a subset of U. They're all subsets. They're always subsets of U. But of course the opposite isn't true. The universal set is not a subset of the other sets, generally. So how does this apply to our problems? Let's see if we understand it first. List the elements of U, A, and B. So use this diagram and list all the elements of those sets. Okay, well U, what is it? What are all the elements we're working with? I see a 1, a 2, a 3, 4, 5, 6, 7, 8, 9. I see all the numbers 1 through 9. The set A is part of that set. It's a subset of the universal set, and it has the numbers 1, 2, 5, and 6. B is just the numbers 3 and 9. And you should hopefully see that the numbers in set A are in the universal set. The numbers in set B are also in the universal set. There's some numbers missing, but those are both subsets. So the question, is A a subset of U? Yes. Of course it is, because the numbers or the elements of A are in the universal set. Is B a subset of U? Yes, as well. It has to be, because the universe is all of the possible elements. And it says here, are A and B equal, equivalent, or disjoint? Blast from the past. Equal means same exactly. All the elements are the same. Equivalent means same size. And disjoint means none of the same elements. Well, what do you think it is? I'll give you 5 seconds. 5, 4, 3, 2, 1. It's disjoint. A and B have no elements in common. Okay, that's pretty obvious. I mean, if you look at the Venn diagram, look how separate they are. They're not touching each other at all. They're not intersecting. They're not unioning. They're totally separate from each other, so they're disjoint. Let's try another exercise. Ooh, what do we have here? What is U called in this diagram? What's the universal set for this particular situation? I'll give you a chance to look at it and think about it. Pause the video if you need to. What is our universal set? I guess there's a couple ways to look at this. I would say that U is the set of the Avengers. It's tempting to say it's the Marvel Universe, but these aren't all the Marvel characters. So I would say U is the set of the Avengers. And then it says, let I equals Iron Bros. These are names that are given on the diagram, by the way. I is Iron Bros. S is Science Bros. Find the intersection of I and S. What do you think it's going to be? Take a moment, pause the video if you need to. What's it going to be? What's the intersection of those two Venn diagrams? You might not know his name, but I hope you do. I hope that this isn't a completely ridiculous request. Where do these two things cross? They cross on Mr. Robert Downey Jr., also known as the Iron Man. Or Robert Downey Jr. If you wanted to write it that way, depending on if we're looking at the actor or not. Okay? But as long as you could note that the answer was Iron Man, or those two things intersect on him, that's the answer I'm looking for, okay? And you can make all sorts of interesting things here, and this is actually a cool diagram. You can make sense of it yourself if you like. But the idea is that we're given a universe of characters, in this case the Avengers, and we can do some set intersections and unions if we wanted to, or just basic operations. So finally, let's do complement. This video is almost finished. The complement of a set is all the elements not in that set, but still in the universal set. So the complement, all of the elements not in the set that we've done the negation of. Just like, zeros became ones before, we're going to just do the opposite, essentially take away those numbers and look at the universal set. So we're subtracting the elements in one set from the other. What does that look like in the case of an example? Let's look at this example. It says, given U equals all positive single-digit numbers, all positive single-digit numbers. What are all the positive single-digit numbers? That's the first thing we should look at, because it's asking us, well, first of all, okay, I'm going to write out what all the positive single-digit numbers are. 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay, those are all the positive single-digit numbers. It gave us the set B. It's the numbers 0, 1, 4, 5, 6, 7, and 8. And we need to find the complement of B. Then illustrate it using a properly shaded Venn diagram. So if we know what B is, so it's a good idea sometimes to write it out if you're not sure. B is this set. Not B, or the complement of B, are all the numbers that are not those numbers. So I'm going to look at these numbers here and take them away from the universal set and see what I'm left with. All right? So it's not 0 or 1, so it's not this. It's not 4. It's not 5. It's not 6. It's not 7. It's not 8. So the numbers that are not 0, 1, 4, 5, 6, 7, 8, but are in the universal set are 2, 3, and 9. Okay? How do we represent that in a Venn diagram? Well, if this is our set U, and this is our set B, what are the numbers in B? Well, 0, 1, 4, 5, 6, 7, and 8. I've used all those up in B. What's left that is still in the universal set? Well, I didn't use the number 2, I didn't use the number 3, and I didn't use the number 9. Okay, 2, 3, and 9 are the only numbers that have not been used. They are all the numbers that are not B, or in other words, the complement of B. And how we would shade this? It looks like this. We shade everything outside of B. Take some time to color that in with pencil. You can do some pencil shading on it. So not B is that whole empty space outside of B. By the way, the shading is a way of visually seeing the rule that we're working with without having to necessarily know all the numbers. Sometimes we'll just shade the diagram, we won't even care what the numbers are. All right? So if that didn't make a lot of sense to you, you might want to rewatch the video, try the question again from scratch, see if it makes some sense, okay? And the last thing I'll ask, because this is the last slide we're going to do today, the last page. Page 41, this is another video that will explain to you what it means to have a universal set and what it means to have a complement, all right? So especially if page 40, the previous example, didn't make crystal clear sense, it would be a good idea for you to watch this video. I know it's 7.5 minutes, but that could be 7.5 minutes that sets you on the right path for the rest of this entire unit. Okay, so that's it for today's video. I hope you learned something. I hope it wasn't too confusing. As always, let me know if you have questions. I'm here to help. That's the entirety of my job, is to help you out. So good luck with it, and have a great night or day, and we'll see you in the next video.